Okay, answers from yesterday. Don't forget to skip ahead if you think that you are good, but I would probably at least go through and pause and double check your work. So no, you can't fold it forever. They proved it on Mythbusters. It actually has nothing to do with the fact that there's too many layers. It has to do with the fact that the corners and the edges start bunching up too much for you to actually keep folding it. So even if you had a piece of paper that was the size of the universe, you couldn't actually fold it, because as it got folded over and over and over again, you'd end up with these big bunchy corners. So it's really crazy. You should go find that Mythbusters clip sometime. Not right now, but later. And so the 3 was saying if you could actually just cut it in half, then you could just keep stacking the paper and it would get super, piece of papers would get super tiny, but you could do it. And so an expression would be 2 to the 16th, and 2 to the 16th is 65,536. The checkerboard problem. I don't know what happened to that other one. Anyway, the checkerboard problem is super crazy, but basically it's saying on the first checkerboard square you have, and you should look carefully at this, the first checkerboard square was 2 to the 0, right? And then the second checkerboard square would be 2 to the 1, because 2 to the first power is 2. The third checkerboard square was 2 to the second power. And so you keep going all the way, and you get 2 to the 63rd power for that many checkerboard boxes. And 2 to the 63rd is, I don't even know how to say this number. This is hundreds, thousands, millions, trillions, billions, something. I don't know what that 9 stands for off the top of my head. So, oh, here we go. 9 quintillion, 223 quadrillion. Oh, I knew quadrillion. And then trillion. I mean, it's crazy. So, props to that farmer or whoever was in that legend that figured that out. And here is this. And so if you invest, this second one was saying if you invest $500, it's going to double every 12 years. And so it would, after 12 years, it'd be $500, or it'd be $1,000. Another 12 years, it'd go from $1,000 to $2,000. So that's how that works. See, it's not 500, 500, 500, 500. It would be 500, 1,000, 2,000, 4,000, 8,000, so on and so forth. Okay, just going to move on. All right, today we are doing, you should fill this out while I'm talking, the opening exercise. You should do it right now. But today we're talking about figuring out whether number sentences are true or if they are false. So if I were you, I would pause it and try and fill out as much of this table. Right now I'd pause it and then unpause it when you're finished, just to see if you actually know what these things mean, double check. But I am going to reveal them in just one more second. Okay, so this first symbol, hopefully you got that one, and that one is equals. And so an example of equals would be, 2 equals 2. Or you could say that 2 plus, the expression 2 plus 3 equals 5. It just means that both sides, it means both sides of the equation are equal expressions. This is an expression, and it's the same as this expression. Greater than an example of that would be 3 is greater than 1. The reason that we say this symbol is called greater than and this symbol is called less than is all in how you would be saying it as you read it from left to right. So if I'm reading from left to right, I'm going to say 3 is greater than 1, 2 is less than 7. Just kind of how you read it. And these two might be new, but these, you might notice, have a little line under them. They're a combination of all these three symbols. So this is, by itself, this would be less than, but since it has that number under it, it means less than or equal to. So an example of that could be 2 is less than or equal to 3. 2 could also be less than or equal to 2 because it is or equal to. And the other one is greater than or equal to. So we could say 5 is greater than or equal to 1, or we could say that 4 is greater than or equal to 4. Those are examples that would work for that. Greater than or equal to expressions are super helpful when you are, actually I think that they're more helpful oftentimes than the greater than or less than. You think, if you want to buy, if you have $200 that you want to spend at Disneyland, your expression shouldn't be, X is equal to $200, because you could actually have more than $200. You need at least $200. So the expression that you would want for that is, your amount of money, for this random example, your amount of money could be greater than or equal to $200, because it's okay to have exactly $200. It's also okay to have more than $200, but you need at least $200. So for this first one, I'm just going to kind of tell you what you're doing down here. So what we're doing is we're going to substitute values. So this says, substitute the 8 in for x into these equations right here, or as they sometimes call them, number sentences. A lot of times they say number sentences if they're also inequalities. And then you're going to say if it's true or if it's false. And if it's false, you're going to find a value that would make it true. So let's go up here and I'll give you an example. And for all these examples, I'm going to substitute 3 in for x. So if I had the expression, let's say, x over 1 equals 3, I'm going to take my 3 and substitute that in for x. So that would be 3 over 1 equals 3. Well, what's 3 divided by 1? Is it 3? Yes. So this is true. I don't have to find anything. Here's a second example. So 3 times x equals 12. We want to find out if that's true. So we could say that that's going to be 3 times 3. Right? We're substituting our 3 in for x for these examples. And does 3 times 3 equal 12? No, that is false. But what value could we use for our x that would equal 12? Well, I know that 3 times 4 is 12. So x could equal 4. If x equaled 4, then that would work. And a final example could be 5x is greater than or equal to 20. And so if I put in 3 for this, that would be, this would be 15 is greater than or equal to 20. And is 15 greater than or equal to 20? No. So that's false. That's false. But I can think of 5 times what is 20? 5 times 4. So x, right? This x could be 4, because 5 times 4 would be greater than, it's not greater than 20, but it's equal to 20. But if x was anything 4 or greater than 4, then that would work. So x could be greater than or equal to 4. So 4 would work, 5 would work, because 5 times 5 is 25, which is greater. 5 times 6 is 30, that's greater than 20. So anything more than 4 would work. So that is an example of how to solve one with an inequality. So that's pretty much, for some reason this wants to follow me, so I'm going to delete this guy. whatever. It'll follow. And you're gonna work on the exercises, and that's it. Happy Thursday.